Hi guys, welcome back. Next up, we'll have Herbert. So currently, he's a software engineer at Allium. Previously, he used to study at NUS, and he's also an alumni of NUS Hackers. Give a round of applause to Herbert.
I'm trying to figure out how to mirror my screen. It's kind of the anti-clickbait. Hi everyone. Thanks for coming to my talk for now. So yeah, as Justin said, I'm currently a software engineer at Allium, and I previously was in NUS sectors, which means that I also hosted these events before. And as a previous host of these events, I know that 50% of you are probably here for the event talk. Another 50% is probably only for details. And if you want to that, and like maybe you're like the remaining 1% is like, oh yeah, I kind of feel bad for this speaker, like I just stay here and watch. So first of all, if you do feel that, don't feel bad. It's okay. Like it's Friday evening, you have dates and libraries. But I mean, let's say you're here anyway, right? You'll be like, oh, well, what is this talk about anyway, right? Moving terabytes of data around. It's like, I don't even understand that. And like, actually, when I presented this to my colleague, like, he actually said, actually, it's not too hard to move terabytes of data around. You can just put it in hard disk and send it over single shipping. What's so hard about that, isn't it? And I think, of course, this is like pretty dumb, right? But I think there's also some truth to this in a sense that this problem isn't very well defined. Like, like obviously you can do this, but I think there are important questions to clarify here, which is, okay, so what's the data, right? Like, what is the data that we are even living on? And now that we know what's the data, then where are we moving it down to? Like, these are the first questions that we need to answer. And so for that, I am going to segue a bit into something that seems a bit unrelated, which is crypto. So who here has played with crypto before? Don't be shy. Raise your hand. So you over there, what do you play with? I understand that. Yeah. How much money have you lost? Maybe. 500. That's unfortunate. Yeah. Well, it's big enough for a student, I suppose. But I think, okay, so crypto, right? But let's say, especially NFTs. We have played with NFTs before. Oh, you do have played with NFTs before. And you too. What do you do with NFTs? Buy, mint?
No, when BTC come up with their own NFT, I tried it before.
Oh.
They are on ordinals, yes, they call it ordinals. And they try to put NFTs into Bitcoin trade.
Okay.
So
that's kind of intense actually. But here is like, typical degenerate that just like buys and sells NFTs, trades them. Yeah, well, I guess no one because it's kind of generic. But so I have a few friends who likes to trade NFTs, and like sometimes they like to go to like the big name, right? So like let's say there'll be OpenSea. Maybe you have heard of Magic Eden before. Maybe you have heard of Blur. So those are some of the newer ones. But some of my friends also try to venture into some of those less known marketplaces. Like for example, like some of you may know OKX, the exchange, which is at the bottom left. But recently they actually also launched an NFT marketplace. And for these friends of mine, actually having NFT marketplaces hunting them can be quite lucrative because when you, let's say, trade things in these NFT marketplaces for the first time, you can get these points which can exchange with some rewards. And these rewards can actually be quite substantial. So you can imagine that, okay, NFT is one thing, right? But you might think like, okay, isn't it great if I can get a list of all the NFT marketplaces and I want to know, okay, which ones are popular, which ones are not so popular, but maybe they are budding, and maybe if I'm early, I can go there first and like get all the rewards. So you can see here, I put some two graphs from this website called nftpulse.org. So actually, you see it is actually quite simple, right? This is just marketplace users, which is like, okay, I go there and trade, I go there and not trade. Or it's marketplace volume, which is that, okay, if I trade, how much is it, right? And then I sum it all across all the trades. And then you get that number over here. So this is like the kind of data that we are talking about in this situation right now. Which is that, okay, so we have the blockchain, right? And from these blockchains, how do we get into these numbers over here? Okay, so much talking about the problem. I realized that I haven't really introduced properly about myself first. So yeah, as Justin mentioned, I'm Herbert, and I also graduated NUS from 2020. So actually, that's, if you realize, that's the COVID year, and it's kind of sad because I don't really have a proper graduation. And as Justin said, I was also part of the NUS Hackers Core team. So as I mentioned, this was me in my graduation. Well, graduation. This was me in front of my TV, and like, you know, it was a very lame graduation. They have like a live stream, and they just show my name there. And it's like, well, it's something, I guess. And this was me doing hack and roll in one of the. So I'm assuming that most of you here should know hack and roll, right? Like this is like their annual hackathon. Yeah, actually, like organizing these NUS Hackers events is something that is always very memorable for me. And like these hackathons, and like, you know, staying up until 3 a.m. to help people who struggle building Telegram bots. But you know, even though I have like a bad graduation, I think that all makes up for it. But I mean, enough of the past, right? So right now I work at this company called Allium. So at Allium, we serve crypto data, and you can see the logo there. And so you might be thinking, like, okay, this is crypto data. Well, what is crypto data? Like, is it like I'm going to sell you shit coins and scams and that kind of thing? So fortunately not that kind. Although, of course, if you like to trade shit coins, like, you're also free to join us. Actually, there's quite a bit of us who like to trade shit coins. There's quite a bit of us also don't trade shit coins. Really quite cool. And so what crypto data means is that, you know, we solve the problems that I outlined like previously. So in particular, for example, NFT Pulse, the numbers there were built from us. And we ingest all the blockchain data and we surface that to those dashboards. So just one little plug is that we're actually hiring. So if you're interested, you know, talk to me later. And I also have some colleagues there which you can talk to them. But okay, you know, enough about me, right? Let's go back to the problem, like how to get to NFT analytics, which is numbers that you see earlier. And actually, if you think about it very closely, like not very closely, right? But like in a short time, you might think that, hey, actually it's not that hard, isn't it? Because it's really just, okay, like read data from blockchain, get some, blocks or transactions, transform them to NFT trades, and then you can just surface that to the dashboard. And, you know, maybe if you have taken the database course, or like you have like learned SQL before, yeah, maybe that's just a group by and a sum. That's not too bad, isn't it? And on surface level, it could seem like so, but actually, if you think about it, you know, the problem here is like scale. Like the fact is that crypto is big. I mean, Bitcoin has been here from 2009, so that's like 15 years. Ethereum's from 2015, that's 10 years. So actually, if you do a quick count of the size of Ethereum, it has around 1 block every 15 seconds, and that's 1 kilobyte per block. And you know, with 2 million blocks, so that's like 2 million blocks per year, and that amounts to around 2 terabytes a year. So that's just for a year. And if you multiply that by 10, that's 20 terabytes. And then if you think about, for example, another chain that you might heard now is called Solana. So Solana is even faster. It's 1 block every 400 milliseconds, and the block is even bigger. It can have 3 megabytes per block. So that's, if you calculate that, that amounts to like 240 terabytes per year. And Solana has been here from 2020. So 5 years, that's like, you know, 1,000 plus terabytes, right? So that's already in the petabyte scale already. So we could even say that the top is how to move petabytes of data, because there's really quite a lot of data. And if you try to store all of this in Postgres, right? At first glance, it seems like a good idea. But the problem of Postgres is that actually, you know, so the thing about Postgres is that it's actually amazing for web apps. And you could say that it's best by hand, right? Because it's been here since, I don't know, 1990 or something like that. So that's already 35 years. And yeah, you could say that most websites in the world, maybe not most, but a lot of them use Postgres. But at the terabyte scale that we mentioned earlier, so this actually breaks down because there's really just a lot of data. And, you know, especially if you do aggregations and joins, in the sense that if you just want to get one row, then you can imagine that Postgres does some kind of primary search, right? And from this primary search, you get the data. But then if you try to aggregate them and then try to join them with other tables, then you can imagine that you need to scan 1 petabyte, you need to scan another petabyte. Well, that's gonna take forever. So in fact, I can show you a demo right now. So, okay, I hope that's enough zoom. So let's say we go to Ethereum, right? So this is one of the databases that we maintain at Allium. And yeah, let's say we do this kind of query. So let's say we want to figure out, okay, how much gas do we consume in the year 2025 in Ethereum? So if you look at this query, it's actually pretty simple, right? You just sum all of them, filter by some block timestamp. But actually, if you write this, yeah, you see that it's just like really slow. And this even just for 2 months of data, right? Because like it's only like February. And as I'm speaking now, it's still running, it's still churning all through all the rows. Plus, if you think about it, it's trying to go through all the tables and scan one by one, right? The rows. And then it's gonna sum up all of them. And that's really just a lot of data. And imagine that if you're a user and it's just gonna show the spinning loading dots forever. And yeah, it's not even done. So really cannot. So I think especially aggregations and joins. And so of course we talk about the query time, but I think correspondingly is also the cost. So what do I mean by the cost? First of all, you need to store terabytes of data. That's a lot of data. Okay, I mean even before that, can you find a hard disk that can store 1 petabyte of data? That's probably really hard. But even if you can find one, that's probably gonna be really expensive. So it's actually really not that easy to store all this in Postgres. But what does that mean, right? So that means we need a better database. So what does a better database look like? And I think you could say that this is quite easy. You can search, Google search, okay, I want a better database. And then you can try to find something. And when you try that, then you'll see that actually there's a lot of databases. Like a lot of them. And I mean, to be fair, this is not just databases, there are also data tools. But you might be overwhelmed looking at this. And actually, when I look at this, right, this reminded me when I was at NUS and I was like learning front end back then. Because like when I joined NUS, I actually don't know any programming. And I was like, okay, now I want to learn front end. How can I want to design cool websites? And when I want to learn that, I was like, oh, there's so many of them. I don't know which one I want to learn. I guess jQuery looks cool. Let me learn jQuery. And if you think about it, yeah, I mean, you can easily get overwhelmed. But I think what I realized from my experiences is that, okay, technology is one thing, but I think more importantly is like, okay, what are kind of the principles that I can get? What are kind of the big ideas that I can gather from each of the technologies, and I can learn them and I can apply them. So, for example, for front end, like one of the things that I learned that I thought was useful was the notion of a virtual DOM. And the other thing was also like, how to abstract components into like one place instead of having separate files for HTML, CSS, and JavaScript. But that's for front end, right? And for data, there's a bunch of them. But you could say that the most important part is the notion of a row-based storage versus column-based storage. So what this means is that, so for example, for Postgres, you store data row-based. So what that means is that, okay, this is one row of data, and you're gonna store them all together in one place. And then this is the next row of data, and so on and so forth. And so this is ClickHouse documentation specifically. I think ClickHouse does a good job at showing what the difference would be. So imagine that just now we try to aggregate them, right? So this is kind of what happens when you do a row-based aggregation. Is that you have to scan, get all the data, and then now finally you can get the dashboard that you want. But with column-based solutions, they are all stored together. And I think the advantage of this is that you can get all the data that you need located in one thing. Because let's say we can store 100 columns, but I think in reality, sometimes we only need one column or maybe 2 columns. So it's useful to be able to get all the data that is located together in one column and directly get the dashboard from there. So just now I talked about, okay, well, Postgres finally returned. That's kind of long. But so, for example, a modern database that does column-based support is this thing called Snowflake. I can do that by using SnowSQL. So if I try to like query this exact thing over here, Okay, so our syntax is a bit different. So there's Ethereum raw connections, and you can see that. Okay, I guess it's still a bit long, but if you wait a bit, it should return. And okay, well, there you go, right? And like this takes 9 seconds, which is still kind of slow, but if this Postgres query will probably take minutes. So that's already at least one order of magnitude better. And not saying that we should use a column-based storage for everything. I think in particular, this kind of column-based storage is very useful if you are doing queries involving aggregations and you're trying to like get analytics of like many things. But for example, it might not be as suitable for a web app because you might need all the columns in one way. But so anyway, right? So this is just one of the things that is like kind of important. But there are more others. If you're interested, you can talk to me more later. But I mean, enough about that, right? So now let's build. So let's think back about the solution for our problem now. So okay, so we have a blockchain, and I want to transform them to blocks and transactions. And I think I want to I don't really want to go deep into this. I think like very hand-wavily, there are APIs on the blockchain. You just scrape them, just store it somewhere. Okay, where is this somewhere? So this somewhere could be Snowflake, for example, as I showed earlier. Or I mean, there's also a lot of other things like Databricks, BigQuery, ClickHouse. As I mentioned, there's really a lot of databases. If you're interested, I actually just found earlier as well that there's this DBDB, which is the database of databases. I thought that's kind of funny. But yeah, so from blocks and transactions, and then we will transform them into NFT trains. And maybe you can think of it as like, okay, so of course this is very hand-wavy, right? Like it's not gonna say the transaction that okay, this is an NFT trade. But let's just say for the purpose of this talk, it's like okay, select from transactions, and then we choose the one that NFT trades, and so on and so forth. So this all seems good, but if you recall, actually just now the Snowflake is better, but it's still kind of slow, isn't it? It takes like around 10 seconds to do the numbers that you want to show. And remember that that's only for 2 months, but what you want to show aggregations across like 1 year or even 10 years. That's gonna take very long. So I think the insight here is almost like if only we can cache this complicated query over here, like from blocks and transactions, we want to get NFT trades data, but there should be some way of caching this, right? Because like if I query it and if you query it, maybe like probably the answer is gonna be. And so fortunately, databases have solved these problems, and they have come up with this notion called a materialized view. And a materialized view is a way to almost cache it. So in the sense that you can run this query, and then you can save it in storage, so that you can this complicated query can then be transformed to a materialized view. And then you as the user can query directly from this materialized view over here. So it could now just be a select star from NFT trades, instead of like selecting all the way into the raw data at the beginning. And so if you actually want to use this, I think most of the syntax looks like this. I would say create materialized view, and then you can put in the query. And then let's say the data is stale, right? And then you want to refresh that materialized view. Then you can just write refresh materialized view, and it's gonna recompute all the state that is available from the raw data. Okay, so that's good. We have this thing called a materialized view. But I think with the amount of data that we are dealing, which is terabytes of scale, I think this might not even be enough. And I think there are a few reasons for that. First of all, this data actually can get stale over time, as I mentioned, right? You need to run refresh. But I think this is really not such a big problem in the sense that you can just run, it on a cron every hour or something. Or maybe, like depending on the cadence that you want. But I think even apart from this, like the query itself can get really complicated. And you can see here that, yeah, so like this, a snippet of our actual NFT trades. And this actually spans like thousands of code, like literally SQL code, thousands of lines. And if you think about it, that's kind of crazy, right? Like, this kind of stupid. Like, what's the meaning in this? Realize it's not as simple as just writing 3 lines of code, right? So I think the complexity here can be a problem as well. And the last one is going back to the sheer amount of data. So this I have is a graph of the number of Ethereum transactions. And you can see that at the beginning, at 2015, it was like almost nothing. But now at 2025 February, it's actually around 3 billion rows. And if you think about it, if you try to refresh a metrized view, there is 3 billion rows. So forget about everything that we said. If you try to metrize a 3 billion rows, no matter what, it's gonna take really a lot of time. And then let's say you metrize these 3 billion rows of data, and then what if suddenly, oh, my SQL has a typo. Uh-oh, then I need to restart everything. And then you need to sit down there and wait again. And not only do you have to wait, you also have to burn money because you have to run this computer. So that's kind of annoying. But fortunately, people smarter than me have come up with solutions than this. And I think one of the breakthroughs in the data space recently, it's gonna be very soon, is this tool called DBT, which actually stands for Data Build Tool. But as far as I know, no one really calls it Data Build Tool anymore. I think pretty much everyone just says it as DBT. And this DBT is actually pretty cool and convenient because it solves a lot of the problems that I mentioned earlier. So for example, instead of maintaining a SQL file that is like, let's say 3,000 lines of code, it can just do, a bunch of tables that we separate. And so I think the way you look at this here is that you can think of these data as like some tables. And then on top of these green tables, you can build these blue tables, which is like metrized views or their views, and then you can build on top of each other in this way. And the way I think about this is similar to the way that we do programming, really, in a sense that, it's useful to encapsulate your tables, abstract them. It's useful to, not need to maintain such a giant function, right? And it's useful to break them down. And like, okay, I mean, this is like a simple example. I think the NFT traits that I showed you just now in reality probably looks like something like this. Like there really is a lot of tables that we maintain. And I think this is partly because there are so many chains, there are so many marketplaces, and we have to aggregate all of them into one table. So actually, if you go over here, this right here is our final NFT traits that we give to our customers. And behind the scenes, there's really like a lot of tables that we build and maintain. But I think without DBT, if you are to maintain this 3,000 line of code, that's pretty crazy. But with this style tool, you can like just work on a snippet of a table. And actually not only that, right? You can also build on top of each tables. Because let's say, for example, right here, I don't remember which one, maybe this one. This is like maybe like token prices, which is like, okay, this NFT costs how much, that NFT costs how much. So that can power our NFT traits, but that can also power other things, like for example, I don't know, like NFT mints and the kind of thing. So it's also useful to like be able to like build on top of each other. And the other powerful thing about DBT is this thing called incremental metrization, which is to say that, for example, in this green box over here is all of our data. And we already have existing model that we metrize, which is this blue square over here. And now we have new records at red. So normally, if you do a normal metriization, you need to metrize and you need to recompute the entire green box. And as I mentioned, that's really time consuming and compute consuming. But now with DBT, we can do this thing called incremental metrization, where we realize that, you know what, this blue thing, we don't need to recompute that. We kind of already know the result, right? Like these transactions stay the same, the NFT traits stay the same. But the red new records is the ones that we actually care about. And DBT is smart enough to say that, okay, I see that the blue ones have already existed, so I'm just gonna compute the red one. And I think the nice thing about this is like, if you remember this graph over here, right? So previously I said that now there's 3 billion, but now if you look at the amount of data that is new per month, it's actually just this yellow box over here, which if you see comparative to the blue box, to the blue bars, I mean, it's actually very, very small. And this makes the amount of data very manageable. This makes the, this makes the kind of things that we do become very manageable. And like, instead of like simply needing to like deal all with a terabyte scale, we can just take things incrementally according to the throughput of the data. So yeah, time speed is very fast. It's actually pretty amazing. So, okay, so that's cool. So this is DBT. And now with DBT, then now we can even just put that in a dashboard. And you can think of this architecture as like, okay, we get some data, put it in Snowflake, and then we transform that into NFT traits, which is like and this is done via DBT so that we can manage the complexity. And then this dashboard can just query these NFT traits over an API. And then like we can get the numbers that we see just now in NFT.org. Okay, let me read more. Okay, this is cool and all. Like, now the entire world can see, okay, which NFT marketplaces are winning and which are not. But now, so what happened around a year ago, let's say, is that people see this and people like, oh, you know what, that dashboard that you showed us, actually that's kind of cool. And like maybe I'm like like a big company, or maybe I'm a hedge fund and that kind of thing. And like, yeah, you know what, that NFT marketplace data is very cool. And I also want that data in my systems. So you could have like, some people that approach us and they'll be like, want to do this for our own analysis. Maybe you want to do this for, I don't know, maybe these are also NFT marketplaces and they want to know in a more detailed breakdown, okay, maybe what kind of NFT should I put more in my marketplace, for example. And so at face value, this also seems simple, right? Because, well, I have data, I can just show it to you in the same way that the dashboard is, queried from the NFT traits. But the thing is that I think this is not as simple, and I think in particular because people can come from different countries. Like maybe we have like Japanese clients, maybe we have French clients, and these are from very many different parts of the world. And if you think about it, well, okay, so what, right? Like there's the internet. I can just throw the data over. I don't care. But I think in reality it's not that simple because in the cloud, there's this notion called data egress. And data egress can be expensive. Okay, so what's data egress? Data egress is data that I bring out of cloud usually via the internet. So let's say I upload some photos to S3, which is in Amazon Web Services. And then maybe I post that in a website. And maybe you open that image. So essentially I'm telling S3 to send that picture over to you. And if I do that, that's considered data egress. And in low amounts, data egress is actually not bad. So this is the exact amount for S3. So like, okay, maybe the picture is pretty small. If I just send 1 gigabyte, that's just 9 cents. That's pocket change. But if you start to deal with the terabyte scale, this actually adds up. Because if you multiply this by 1,000, that becomes like $90 per terabyte, just for the first year. And then, okay, it does get cheaper. But if you calculate, for example, 100 terabytes, that's $7,000. That's a lot of money. Like, imagine that, like, there's this guy who wants our data, and he's from Japan. And we're like, oh yeah, I know our data is cool, but if you want this data, you've got to pay us 30,000. And we're like, what? Why do I have to do that, right? Like, that's kind of crazy. And imagine that we have to do that for all the regions that we replicate. And like, so our data is mostly in the US, but imagine now can only say that, oh, if you have our data, you must be in the US, or you must have some data in the US, like some kind of data center in the US. And that can be very prohibitive to some of our clients. So actually the topic of data egress, right? So probably a lot of you here haven't really used the cloud yet. But I think like once you go to the, like, maybe some startups, like some smaller companies, like this can actually become a recurring thing. So actually you search like data egress horror stories, you can see like people, oh, I didn't set up my egress and then now I get a $300,000 bill. So this kind of thing is actually quite common. So maybe one takeaway that you can have from this talk is that, okay, data egress is expensive. And maybe just by that, you can already save your company $300,000. But yeah, actually a lot of people make these kind of mistakes. But, so going back to this problem, right? How do we make sure that when a client wants to onboard us that is not from the US, then they can do that without paying an initial upfront cost that is so much? And so I think for this, we found two pieces to the puzzle. And fortunately, they are all like pretty recent technology, which is I wouldn't say fortunate, or rather it's like more like, I think it's cool that, with recent technology called breakthroughs, we are able to get this kind of thing. And the first one is this thing called Cloudflare R2. So R2 is a data storage in cloud. that is hosted by Cloudflare. So actually this R2 name is kind of a pun because like for Amazon, they have something called S3, right? And you say that you're better, so like you shift one and then S before S is R, for 3 is 2, okay, R2. Actually, that's kind of late in my opinion. But maybe they, but so the cool thing about R2 is that if you notice in their pricing, their egress is actually free. And this is actually pretty crazy because, like imagine that the $7,000 that we mentioned now becomes $0. And so I haven't actually like really figure out why Cloudflare is able to get this for free. But I imagine that it's only possible because Cloudflare almost powers the internet right now. And like they have like so much, connectivity in a way that they can offer this kind of service. So you can imagine that, okay, so how do we use this R2 to solve our problem, right? And like very vaguely, you could say that I have data that is in Snowflake and feed traits, and I can put that into R2, and then I can give that to other people for free. Because as I mentioned, once you put your data in R2, egressing is actually free. Okay, sounds simple enough, but then the question becomes, okay, how do I do this? Like, how do I put data from Snowflake to R2? Like, I guess I can dump them like CSV files, but that's gonna be very annoying, right? Because I imagine that, oh, hey, I'm actually using Snowflake in Japan. Oh yeah, I'm gonna give you some CSV files, and they'll be like, what? I want Snowflake data. But fortunately, there's a second piece to this puzzle, which is this thing called Apache Iceberg. And I think this was also only from 2022, maybe? I don't remember. I think R2 was 2021. And so what is Iceberg? Iceberg is an open table format, which is to say that Iceberg is just a specification on how you want to store files that you can use to power your databases. And I think the cool thing about Iceberg here is that, first of all, it has many integrations, let's say, to a lot of these like databases. So that could be like Kafka, Flink, Snowflake. I don't know. I think I mentioned earlier there is what's in Iceberg? Databricks may be coming soon, I think. Yeah, I think ClickHouse might also be coming soon. But there are a bunch of databases that offer support. Okay, if you want to put your data in Iceberg, you can do that. And this Iceberg data is in the form of files, and you can put them in really wherever you want. You can put it in a cloud. And there are many clouds that support them because it's really just a collection of files. But you can even put it in hard disk as well. And so the cool thing about this now is that we found the solution, the second part of the solution to our problem, which is that we can put this data in Iceberg format. And now, if people want to read this data from Iceberg, they can just spin up a Snowflake account, and Snowflake will automatically read this Iceberg and almost import this to their Snowflake accounts. And the good thing about this is now, we just need to pay the egress once upfront, which is that, okay, we egress from our cloud provider, which in our case is Google Cloud Platform. We do that through R2. And then, okay, we pay once, but now every time anyone comes from any country in the world, if they want the data, we can just tell them, hey, yeah, you can just create a Snowflake account, and then you can just point your data to this R2 bucket over here. So we thought that this is actually like super cool. And I think we invented an even cooler name for this, which is called data teleportation internally. Because in some sense, it's really like, you have data and you can just teleport that to the entire world. And I think that's kind of cool. And I think another thing that is also cool is like also from the Iceberg format that I mentioned earlier, is that now these clients can also use their data provider of their choice. In the sense that, okay, maybe I don't use Snowflake. My data is all in Databricks. But if at the point when Databricks support Iceberg, then now they can also read the data. And maybe another person from BigQuery or whatever. Right? In the ideal world, they will be able to read from Iceberg. I mean, right now it's still, I believe, under construction. But I think there's something cool about this involving like, having a data format that is open source and also currently being adopted with all the big data players so that they can become standardized. Okay, so that kind of ends my talk. So just to recap a bit, I think we learned about a better Snowflake, a better database than Postgres for our purposes. That could be Snowflake, that could be other tools, I don't know. like Databricks, BigQuery, and whatever. And then I also mentioned about this tool to abstract our models called GDP. So there are also other players in the space. One of them is called SQL Mesh, for example. And then we also talk about the challenges of being in a data company, like for example, if you want to replicate your data to other places. And we found out a solution using RTF. So these technologies are cool and all, but I also want to highlight back to this list of infrastructure tools. There is like many, but I hope that I can show that really there are so many tools, but there are also some core things that are central to solve these tools that is useful among them. And I think once you get a grasp of them, and then when you see new tools, you'll be like, okay, I can understand what they do. I can understand what that do, right? And then like now you can easily discern and try to build on them instead of just riding the hype and maybe one day they'll just die or something and like get replaced by another data tool. Okay, so yeah, I mean this is pretty cool and now, but so actually the process doesn't really end here, right? Because okay, in the ideal world, we get data from our blockchain, we put it in our database, we distribute it, everyone happy. But there are really so many things. Okay, like how do you continuously update the iceberg table? And what if our logic is wrong? And then there's missing data. And then if our RPC node is unstable, which is like the blockchain data. And then what if a new NFT marketplace shows up? How do we ingest them? And then what if a new chain shows up? And all of this about NFT. But maybe let's say our client is wallets. And like actually maybe they want our data, but updated in seconds. Then how do you run DP such that it runs in seconds? And I think the list goes on and on and on. And I think it's easy to get overwhelmed when you see these kind of columns. So actually, funny story, right? So we at Allium, like we kind of call ourselves like data plumbers in some sense. In the sense that, I'll say that our job is, not the usual sexy AI ML kind, like let's say you're an actual plumber, right? You won't go post in your LinkedIn, oh, hi, I'm a plumber. Or like you won't like go say to your date, oh, hi, by the way, I'm a plumber. That's kind of, disgusting, isn't it? But then again, actually, despite all that, I think what's interesting about being a plumber is that actually you can see that there are really a lot of challenges that are associated with being a data plumber. And if you try to deal with data at that scale, you try to deal with problems that people try to not care about. All they want is like, oh, I just want to build the newest AI model. Okay, where does this newest AI model, where's the data come from? I don't know, I'll just give it to the plumber. And it's like, I think if you look under the surface, there's actually a lot of interesting problems that you can solve in this space. And it actually is also very useful. And no one really wants to think about it. So I think if you are interested to become a data engineer, this is like probably the kind of things that you think about. And like, the kind of like very big data scale and the kind of tools that you try to use. So yeah, that's all for my talk. Thanks everyone. So if you want to talk to me someday, that's my Telegram. Feel free to talk to me about anything under the sun. And once again, if you're interested in Allium, I put the link again there, allium.so. We are hiring, so if those kind of questions and problems are interesting to you, you're always welcome to talk to me and talk to my colleagues. And
Yeah, I just want to say hi. So Shank here. Have any of you met Shank before? Great. So my name's Ethan. I'm actually the co-founder of Allium. So actually, I'm a Singaporean, but I've lived in the US for many years at this point. Went overseas for school. I think there's one thing to correct about the talk. So Herbert talked about moving terabytes of data around. We actually move about petabytes of data.
yes.
So can any of you guess our infrastructure bill every year? Anyone wants to guess? No? 20 million? Huh? 20 million? Oh, if it's 20 million, we won't be here. We're in the streets. It's $5 million a year, right? So we actually have $5 million a year, and I think for the longest time we have $5 million per year infrastructure budget for only 10 engineers. So we basically pay more per engineer, like $500,000 per engineer per head. So I think you can see it. I think like the slide I want to like emphasize is this one. Let's see over here. Can you guys think about what is our most expensive mistake that was done within 1 minute? 1 minute, a 1 minute mistake. Think of our most expensive mistake that we did at a company. Oh, no, I said like how much money did we lose? And what it was basically a one-click mistake, a single click. Huh? That's about 100,000. 100,000 US dollars, right? So just to give you a sense, like just remember that whenever you move a lot of data from A to B, it's pretty high stakes. In that case, I can tell you the $100,000 mistake we made was that we chose the wrong cold storage mechanism. So we chose a wrong storage layer, and it was one click, and it just went to 100,000, and I remember I woke up at 6 a.m. Oh yes,
We have a top spend.
so yeah, we actually have a top spend of actually it's 98,000. So we have actually a leaderboard in the company of how much money everybody has lost. So
It was definitely 98,000 because
98,000.
we at Singapore realized it early.
Yeah.
Otherwise, it would be like 500,000.
Yeah, and this was like one. And the problem with most of the infrastructure, websites, you normally take 24 hours to get your bill before you get. So you cannot find your mistake until 24 hours later. Right, and I still remember I got the text at 6 a.m. in New York. So we're headquartered in New York, but we also have an office here. And then the second biggest mistake was 47,000. How many of you know OGP? Any of you know OGP? Yeah. So actually, the founding engineer of OGP works at Allium as well. He's based in the US. That was his mistake. Within his first month, he made the 47,000 mistake. So that's, and then the third mistake was actually much. It's more like 12,000. But I think the point I'm trying to make is that if these are mistakes that happen within, like mistakes where you press the wrong button, you write the wrong script, and then you accidentally like make the mistakes. And so like whatever Herbert has been teaching you guys, very important. He said there's only one thing you need to remember. It's just this, right? Data egress is anything related to like big scale data is expensive. And yeah, always just remember that. Be very careful with all the data stuff. And like I think just to emphasize Herbert's point about the data piece. So I think previous to starting Allium, this company, I spent 6 years in the AI space, NLP specifically before school, and I think like the biggest lesson I learned in the AI space was the bottleneck to the best models is the best data pipelines. So just remember that. Like I also learned very early on that it's almost like 99% of the work is the data pipelining piece, and then the 1% is just running that random code you copied off some other GitHub repo and retrain the model. Like that's it. And then the whole entire value is the 99%. And also one more little piece I'll leave with everybody here. It's the most counterintuitive lesson they ever learned. The sexiest stuff gets commoditized at first, right? So whatever the most sexy skill you want to learn right now, that skill will be irrelevant very soon, because normally that's where, like for example, you want to train an AI model, you want to build out, like usually all the big companies will just commoditize that, open source it, where it becomes almost free. And then where you want, if any of you ever interested in building any businesses, right, in the future, like happy to answer questions after this, but usually the most boring stuff is the best businesses to build, all right? So just remember that. Best businesses is the most boring stuff, because no one wants to do them, but everybody needs them. So just remember that. Don't chase the hype. And yeah, so I just wanted to say a couple minutes. So thank you.
Thanks, Ethan.